And welcome to my fourth class on coordination compounds. In the last class, I had a plan to complete nomenclature, but I could not complete to my full heart's content because you guys dragged me to go slow. कोई बात नहीं. We'll be revising today the nomenclature with your doubts and then enter into isomerism. What before that, let me share my screen. What doubt you have? I have given those who are watching directly in the YouTube, for them the file can be found in the description, the link to the solution, the answers of all the names, formula of inorganic complexes. You will find in that file. I had also given you this link to your WhatsApp group. And one what has happened? Something has happened here. Something overlapping has happened. Very interesting. Oh, this yes, there has been a serious, you know, overlapping. This is hexa aqua, aluminium, and that this has been hexamine hexafluoride of ferrate 3. This one and this one has been overlapping with this one. This is really very hmm. Same thing I find here. Did you get this kind of weird overlappings in your file?
No, sir.
So
No,
why
sir.
this has happened? I don't know why it has happened. Anyway, any doubt you have, you can ask me at this moment. Any
That's
doubt?
all
Have you
right.
done? How many of you have
Uh,
completed these few things which I had given? Unless you complete, then how can you have a confidence? For building up confidence, you have to. Yes, Krishna has finished, and who else? Udit has finished, and no one else perhaps. But unless you do that, it will not be difficult to ask me questions. Yes, any question, Krishna, you have?
for a last, sir.
Data.
Sir, nahi.
Just it has been shifted little upwards, so overlapping has happened. The original file, let me look to the original file. It will be better if I look to the original file. Mm, yes. No, this is okay. No, here no overlapping. Last compound, this one,
No,
little
sir.
bit of overlapping.
R1 number. Sir, R1 number.
SAQ2 number 1.
Yes, sir. तो सही
Well,
अन्ना वाला था सर.
you asked me, that is possible. Let me open this. Something has happened, you know. The answers of all the questions I have given those. Good morning, everyone who are watching now directly from the YouTube. Write something in the chat box so that will be in a live communication mode. So we'll be revising a bit of nomenclature which you are supposed to write. I have given the answers in the description box, the link I have given. So you have this doubt. Krishna has this doubt. Have a look. FeONO, NO, SO4, En. Can you tell me what is the coordination number? This is a neutral complex. What is the coordination number? This is nitrite O.
6.
This is -2. So iron is in the plus 3 state. So usually you consider NO as a neutral ligand called nitrosyl. So ethylene diamine is a bidentate ligand, 2 teeth. Let us see what teeth we can account for. This is 1 teeth. This is 1 teeth. 2, 1, 3, 4. So it seems that coordination 5 is very difficult. So also 7. So it is using both the teeth. It is a bidentate ligand sulfato. So this will be a coordination number 6. And we call it ethylene diamine. Then nitrito O. Then nitrosyl. He is asking something different. Sulfato. Then iron. The English name iron 3. Then nothing, because it is a neutral complex. He is saying, why not we take NO as a cationic ligand? If you make this +1, then this will be +2. We will write here nitrosilium or nitrosonium and here write iron 2. It is possible, but it is extremely rare because we will be studying in our theories of ligand metal bonding, the magnetic properties we can predict. From the theory, we can predict whether it is paramagnetic, contains how many unpaired electrons, or it is diamagnetic. So, and then we will measure the paramagnetism. If it will tally, then we will modify. We will say it is not nitrosyl neutral ligand. It is nitrosilium or nitrosonium. It is a cationic ligand. And that has happened. In some cases, it has happened and it has been modified later on, saying that NO is not NO, it is NO plus. So the oxidation state of the metal ion has changed because the magnetic properties were not studied very meticulously. But in this case, it is NO. If nothing is given, that is the trick that you have to adopt. If no mention is given that NO is in NO plus or NO, you will take it as a neutral ligand. 99.9% cases, NO acts as a neutral ligand. I will tell you some exceptional cases where NO is not NO, it is NO plus, not here. Any other doubt?
So what is the upper 3 number good?
I have given you all the answers. What
So
number?
H.
In H. Oh,
Yes,
yes.
sir, একটা
Oh, yeah,
molybdenate
yeah,
হবে
yes,
না?
I understand. So overlapping has happened. Overlapping has happened here also in the second file, which I have modified it. So the first file, it is not. This is tetrachlorido oxido molybdate. He is saying you have told in place of or IUM, you replace by AT molybdenate. It should be molybdenate, not molybdate as I have written. No. Exceptionally, in this case, NUM has been replaced by AT molybdate because the salts, simple molybdate salts, they are already in use. Ammonium molybdate, potassium molybdate. So molybdenate is not in use. So due to its popularity, so NUM has been replaced by AT molybdate, not molybdenate. Okay, I have verified this. That's it. That's all. Shall we start? Any other doubt you have?
No,
And there
sir.
was one mistake I had corrected.
Sir,
Udit had pointed out one mistake I had committed in the answer. Which number, Udit? Quick.
yes, sir.
Are you sleeping?
No, sir.
Quick. We don't have time.
Sir, number 2, bit 7.
Number 2, bit 7. Tetramine. Here I have written tetramine, but here I had wrongly written by mistake NS whole 2. I had corrected it. It should be NS3 whole 4. While correcting it, when I took the reprint in PDF format, then this overlapping has happened. I will fix it and I'll send it the corrected, good looking file, maybe 1 day or 2 days. All the answers, all the names I have given. Any other doubt? Feel
Sir,
free to.
can we have two central atom in a
Yeah,
coordination pair?
that I will be discussing today. That I will be discussing today. And I urge upon you, those who are in the Zoom and those who are watching in the YouTube now or later, you have to practice without looking to the solution I have given. You have to practice minimum these to be very prompt in naming inorganic complexes. If you don't, then you don't expect any good result from attending my classes. I will have 10 classes, minimum 10 classes, minimum, and with increasing complexity. I mean, understanding level. So unless you are thorough in this part, you cannot be thorough in the succeeding parts. So you have to practice. Some practice questions I will be giving after every lesson, and you have to practice. And you can ask me your doubt. I'm putting the answer file in the description box of every um, video after some time, maybe 1 or 2 days after, giving some time to you to answer of your own without depending on my solution file. So let me give you some more examples because you guys are uh, looking good. Can you name this one? And this one. These are the two simple complexes. In the second case, the molecule, the coordination compound has two complex ions. The cation is a complex, the anion is a complex. It's not a binuclear complex. The one which Udit you wanted to know is not that. Here, typically the complex is mononuclear, but the cation is a complex, the anion is a complex. But here, only the anion is a complex. You raise your hands, please. Two hands raised. Krishna and Udit. because they have done. You guys, I left you about 3 to 4 days gap. Still, many of you could not. This will definitely pay a heavy price on your marching ahead with me. The excitement that I am having to make this series of lectures very much essential for those who are aspirants for JEE, IIT advanced level and NEET perhaps, and of course, NEET of course, but JEE advanced level and any other competitive tests. Maybe those who are wanting to appear the national level senior Olympiad, science Olympiad in chemistry, in any other competitive test that will be held. So tell me now, many hands raised, and also those who are watching outside can also answer me the first one in the description, in the chat box you can write down. So I will read out your name, that this guy is watching and is answering correctly, because nomenclature is very important. I would like to ask Ridhi and Siddhi. Anyone? Siddhi?
Potassium hexachloridostanate 4.
Precisely. First, you have to find out the oxidation state. There are 6 chloride ions, so there will be -6, and this will be 2 potassium and +2. So +2 plus x minus 6 is equal to 0. So x is equal to +4. So tin is in the +4 state, and it is an anionic complex. The complex is anionic. The rule, according to rule, ATE will be suffixed to the Latin name in place of the last 2 or 3 letters, like yum, or num. So this will be potassium, as she has rightly pointed out. Hexachloro, you can write down. Many of the books you must have found out by now that majority of the books, they still write chlorofluorocyano. So let us not dishonor them. But since we are hero marka guys, we must write always the latest chlorido. And what you said, stan, yes, Siddhi?
Stanate 4.
Stannate, AT will be there in place of stannum, and IV in Roman in the oxidation state. You understood? Now, who will answer this question? Now the question goes to Amlan.
So tetraamine dichloride of platinum 4.
Tetraamine, double M, monodentate ligand amine dichlorido. We shall also honor chloro if somebody writes, because the book also writes chloro, dichlorido. Yes,
Platinum 4.
platinum 4 IV, then
Hexachloride of platinate 4.
hexachlorido platinate, because this is an anion, AT will be there in place of platinate 4,
Yes,
right?
sir.
So why it is 4? Because if this will be 4, this is neutral, this is -2, the net charge will be +2 here. And if it is 4 and this is -6, the net charge will be -2. So you will yourself decide whether the platinum, usually such coordination compounds will have the same oxidation state in both if the metal is same. Usually, you cannot generalize, they will be always same. So this will be +4, this will be +4. Had it been +2, then this will be +4, then the net charge will be +2, and this net charge will be 4. So you just like you cancel 2 and 2 would have come here. So this would have been a subscript 2 and this would have been a subscript 1. So accordingly, these subscripts will change. So rightly you have answered. So this tetramine dichlorido platinum 4, then hexachlorido or hexachloroplatinate 4, right? So can you write down the name of this compound, the formula of this compound, whose name I will give you? tetramine glycinato. Nickel nickel 2 bromide as a sulfate. So that you will find a subscript uh, below the square bracket. You might, yes, I think. And you have to find out the coordination number additionally and write the structure. This is the formula writing. Tetramine glycinato nickel 2 sulfate. Tetramine, first write down NH3 4 like this. We will list glycinato GLY -1, nickel +2. Then you place alphabetically. You also have to place according to the latest rule. So NH3 whole 4. You have to also place alphabetically, and then glycinato is -1. If it is +2, this is -1, this is 0, the net charge is +1. The valency is 1, but sulfate is valency 2. So the 2 will come here. So it will be Ni NH3 whole 4 Gly whole square bracket 2 SO4. How many of you have done this formula correctly? Raise your hands, please. And those who have understood, we have Sai Satyam, Satyajit, Girija, Arnab, so many guys are now in the Zoom. And I am sure many more are watching in directly from the YouTube. Yes. Somaranjan, good morning. Please interact with me. Use your chat box to write. Have you understood what is going on? Yes. With this much of revision, you have to practice. By tomorrow, you have to practice. I will let us pick up something which we have. Now see, let me tell you that I have already told about macrocyclic polydentate ligands. I have already told you what is a chelate and what are chelating ligands, and also what are ambidentate ligands, also what are flexidentate ligands. Haptic ligands also have told you that if the ligand is cyclopentadienyl or cyclopentadienido, then O, and you write eta. The eta symbol stands for haptic ligands. And if you superscript 5, then all the 5 carbon atoms of this aromatic structure will be simultaneously bonded to the central metal ion. And this is octatetraene. It can maximum hapticity can be 8, but you can have a specific 4 carbon atoms can join. In that case, you have to mention the carbon number which are continuously or combinedly coordinating with the central atom. This is allyl or prop 2 in 1 ido. It can be 3, it can be also 1. Also, this carbon, this CS2 lone pair can coordinate without taking the pi bond into account. Yeah, I have already discussed that. Sigma donor, sigma donor, pi acceptor, sigma donor, pi donor. I have already told you. The only thing which I have not told you is this one. 18 electron rule, effective atomic number, and bicyclic. Now let us come down to our today's program. Here, let us, oh no, these are called binuclear complexes. Four plus. The net charge is 4 plus. These are called binuclear complexes. Nuclear matlab is not nucleus. Two metal ions. If in one complex there are three metal ions, it is called a trinuclear complex. And here there are two metal ions. In one complex ion, there are two metal ions. Bionuclear complex. Sometimes the metal ion are connected to each other. These have no bridging ligands, as we shall see in many carbonyl complexes. We shall be spending a whole class for carbonyl complexes at the end. So there you find large examples, carbon, there is a metal direct linkage. But here you find the two metal ions are not directly connected by a covalent bond. Then it is breached by some ligands. So this OH minus 1, they bridge two cobalt nuclei with 2 electron 3 centered bond. NH2 minus is having a one lone pair, but this is bonding the two cobalt nuclei, cobalt ions by 2 electron 3 centered bonds. So these are given a symbol mu. The mu symbol stands for bridging ligands. How these are named? If both the sides are symmetrical, same arrangement, 4 amine ligand, here also 4, I'm sorry, 4 amine ligands, cobalt. Let us find out the oxidation state of cobalt in each. Hydroxido is a -1, amido is -1, and if the net charge is -4, cobalt supposing 2x, -2 is equal to -4, then 2x is equal to this is +4. This is 4 plus. I'm so sorry. Not minus, plus. If 2x minus 2 is equal to +4, then 2x is equal to +6 and x is equal to +3. So each has an oxidation state of +3. Now, what you write, since these two sides are equivalent, same, identical, then you have to write mu first. If they're non-equivalent, then write mu in between. So mu hydroxido amido. First A, mu amido, mu hydroxido. Since both are identical, then add the two, 4 plus 4, octamine. Octamine, then dicobalt. Cobalt, dicobalt, 3. Or if you do not want to add, then write mu amido, mu hydroxido or hydroxo, as the case may be. Then write bis, write one side, tetramine cobalt 3. Then that will be duplicating. Tetramine cobalt 3 ion. This is an ion followed by an anion which is we don't know, it has not given. If nothing is given, simply you cite it's an ion, it's a positive ion. You are naming as a cationic complex. But if the two are different, then supposing this have been 2Cl2, supposing here had been same but slightly different. The two sides are not exactly same, but there has been two bridging ligands. Here supposing NH3 2Cl2, and this time -1 -2. Supposing this we will keep it in +3 state, this is -1 -1. Tell me the charge of the big bulky elephant ion. Tell me what is the net charge of the elephant. We have to, supposing keep cobalt is in the +3 state, each of the cobalt ions is in the +3 state. So -1 -1 -1
+1
-2 +3 +3. So what is the net? How much?
+1.
336 minus 5 is +1. So the net charge of the complex will be +1 if we keep a cobalt is in the +3 state, because this is -1, this is neutral, this is neutral, this is -2. In this case, you have to write separately. Write triamine, chlorido, cobalt 3, then in between mu amido, mu hydroxido, pune again dichlorido, diamine, dichlorido, cobalt 3 ion. Let us write down. These two sides, they are not identical. In that case, we have to write separately. First, the one which is kept in the left, written in the left, triamine, chlorido or chloro, cobalt 3, then mu amido, mu hydroxido, again diamine, dichlorido, cobalt 3 ion. So did you understand?
Yes, sir.
So and can you name this compound? Have you written that? If you have not written, I'm giving you some time to write down. If the two are non-identical, then you have to write separately, and the bridging ligands prefixed with a mu symbols to be written in the middle. Therefore, while writing the formula, you have been advised to write the mu symbol at the middle. Even if the two are identical. While writing the formula, don't write the mu symbol in the left.
যদি CO NH3 2Cl2 লেফট নিয়ে আসবো তাহলে না চেঞ্জ হয়েছিল
কোটা CH3 which one?
স্যার এই CO NH3 whole to Cl2 এইটা আপনি যদি লেফট
No, these same, but you have to write according to the given formula. You have to write, but same. Whether you write left or right, the complexes are same. If you interchange between the left and right, it will mean one and the same. But it is customary to write the one given in the left side first, and the other giving in the right side next. Clear? Clear?
Yes, sir. Yes.
Yes, sir.
Then I had to tell you one more thing, that 18 electron rule, that is sometimes important for your examination. Although this has been a little obsolete nowadays. When you study the stability of complexes, you will find that 18 electron rule has been little old mudded rule. So let us write down what it is. 18 electron rule, sometimes it is called effective, interchangeably it is called effective atomic number rule, but these two rules are different. It is a different rule. I'll tell you, but it means the same thing, but it is a different rule. So first 18 electron rule says that total number of valence electrons of metal ion in a complex should be less than equal to 18 for stable complexes. It is more than 18, it is an unstable complex. Such a complex will not be prepared easily if the total valence electron will be exceeding 18. It was in the beginning, it was equal to 18. But many complexes were synthesized after Werner propounded, introduced the complexes to the world. Many different types of complexes were prepared where the 18 electron rule was violated very confidently, but still it was found that the complexes are very, very stable. So, but most of the cases you find 18 electron rule is satisfied if you put a less than sign along with equal to. For example, if you say FeCN whole 6 4 minus. So what is the oxidation state of, what is the name of this ion? Who can tell me? Yes, you tell me what is the name of this ion.
Ferrocyanide.
No. IUPAC. Don't tell me ferrocyanide. It is a common name. But if you are asked in your examination what is the IUPAC name of this ion, don't ever write ferrocyanide ion. Yes, anyone? Arnav? Anyone watching from the YouTube? Yes, Udit?
Hexacyanide of ferret double X.
Yes, hexacyanido, or I can also give you credit if you write hexacyano for cyanido, because we do not want to dishonor people. And this is a negative ion, it will not be iron, it will be ferret, ferrum, and it will be et, ferret. And this is -6, this is x, so is equal to -4, so x is equal to +2. So it is in this +2 state. So if you don't practice the few names which I have given, then how can you run with me? It will be difficult. I don't mind. I will be running with even one guy, and the others will be watching, benefiting from this video at a later stage from YouTube source. I will be making and remain as passionate as I am always while I teach. I create a video. Cyano can write down ferret too. So if you find out the valence electron, it is first the number of electrons in n-1d, which is taken as a virtual valence cell. I told you from the very beginning, which many people do not believe it, that n-1d electrons are taken to be virtual valence electrons for transition metals because they take part in bonding. We will see. Of course, no doubt, in complexes, the metal ion uses vacant orbitals, but there is always a reorganization of the valence electrons. So indirectly, they take part, sometimes with a pi bonding to the pi acceptor ligands. We'll know about that later. So n-1d are electrons are taken to be virtual valence electrons, plus ns, if any, plus 2 into coordination number. Because after bonding, the metal ion will be enjoying all the covalent bonds to be taken to the ownership of the metal ion. So calculate what is the total number of valence electrons enjoyed by the iron metal in ferrocyanide ion or hexacyanide ion. This is in the +2 state. So Fe as a neutral atom, 3d6 4s2, but this is in the +2 state. So this becomes 4s0, 3d6 4s0. So only 6 electrons are in the n-1 d plus 0 electron in ns plus 6 into 2. Each cyanide ion will form a dative bond. Both the electrons are to be counted for the metal. So into 2. So 12 plus 6 is equal to 18. So 18 electron rule is satisfied, and hence ferrocyanide ion, so-called ferrocyanide ion, is a very stable complex. But unfortunately, when they found that ferricyanide ion is still more stable than ferrocyanide ion, then the rule got changed, less than equal to 18 electron. So this is in +3 state. So it is 5 plus 0 plus 12, 17 electron. This is hexacyanide of ferret 3. So, so this is also stable complex. This is also a stable complex. 18 electron rule is satisfied. So when became less than 18, then what is the fun of telling it as an 18 electron rule? It is less than 18. So you are mending, you are modifying the law. Stable complex. So it is more stable than Fe +2 complex. As we, that is 18 electron, being 18 electron is less stable, being 17 electron is more stable. But if it becomes 19, for example, I have given one example where you will find, yes, I have given you an example where cobalt, hexamine, cobalt 2, where cobalt 2 plus is D7, 3D7, 4s not. So 7 plus 0 plus 6 2s are 12, 19. So if you solve this, this will be D7, 7 plus 0, NS0, and 6 2s are 12. 19 electron is highly unstable complex. But it's not that it is zero stable, but it is very, very less stable because it is exceeding 18 electron. But very interestingly, in metal carbonyls may be simple mononuclear metal carbonyl, for example, FeCO5. What is the name of this complex, which is a neutral complex? Can you name it? Yes, anyone?
Pentacarbonyl iron
Iron?
0.
Precisely, pentacarbonyl iron 0. Because carbonyl is a neutral ligand, so iron has to be 0. But carbon monoxide is a hero marka ligand. And if you are not able to understand what is hero marka, if you are not an Indian, then perhaps I tell you, this is very typical ligand, which we brand it as a hero ligand, that it is not only a sigma donor, but also a pi acceptor. It will have a double bond character. Each bond has a partial double bond character because of the d pi, p pi back bonding. Oh, I'm shouting. You should not shout. I'm yelling. Sometimes, I remember I was coming from the school of my granddaughter, who is in class 3. Not in this place, the elder son's younger daughter. I was picking her from school. We were walking. It was about half a mile. We were walking, and she told me to tell a story. That is usual that I tell stories. And when I started telling story, I became so passionate that I uh, did not realize that I was shouting. Then she said, Jeji. She calls me Jeji. Jeji, you are yelling. You are yelling. At the first instance, I could not understand what is yelling. Then I immediately realized that I am shouting. She saw, oh, then I looked here and there. There is nobody. And then I said, Khaira, there is no one watching. Then I will not be yelling. yelling now. I'll be slowing down my voice. Don't worry, there is no necessity of shouting. If my viewers are able to hear me, then there is absolutely no necessity of sounding. I just slow down my voice a little bit. So this is pentacarbonyl iron 0. Now let us apply the 18 electron rule. Iron is 4s2 3d6. You have to add all. So 6 plus 2 plus 5 into 2, 10. 18 electron rule is satisfied. And even if there is a binuclear complex, if there is a metal-metal bond, you have to, because, you have to add 1. You have to add 1 because or if you subtract 1 from its d electron or s electron, then you have to add 2. If you do not subtract, you take, this is, I have given an example of a binuclear manganese carbonyl. It is CO5, CO5. Since it is symmetrical, you can call it decacarbonyl dimanganese 0. So if you take all, manganese is 4s2 3d5. So 2 plus 5 plus 5, you have to look for each manganese. Each manganese will satisfy 18 electron rule. So 5 into 2, 10 plus 1. If you reduce one carbon atom of manganese, say 4s, 1 electron is being used here, you make it 1, then you add 2. Since you are taking all the valence electron, but there is a manganese-manganese covalent bond, so plus 1 has to be added. So it is 10 7 plus 10 plus 1, 18 electron. So ceremoniously, the metal carbonyls, whether it is a binuclear, trinuclear, you will find, we will study carbonyl complexes in a very big way later at the last stage. You will find that in most of the carbonyls, the 18 electron rule is obeyed very ceremoniously, exactly 18. That is why the 18 electron rule is even today is important, particularly for carbonyl complexes. Any doubt? You understood? Satyajit? Understood?
Yes, sir. Yes.
Any doubt? Feel free to
So
ask your
plus 1 का
questions.
है ना?
Huh? निश्चय कृष्णा ही तू. I am definitely sure it is Krishna. Is it Krishna?
Yes.
Okay, that will help others who are little slow learners to understand why I added 1. I am repeating. Now, you have to take all the valence electron. Manganese in the 0 state. You have to find for each manganese whether 18 electron rule is obeyed or not. So, since you are taking the entire electronic configuration of 0 manganese, 4s2 3d5, therefore you are adding 1. Had you taken, since 1 electron is used in covalent bond, would have taken 4s1 3d5, and the 1 electron is used for this bond between manganese. So then you have added 2 electron. Here 5 plus 1, 6 plus 5 into 2 for each manganese due to the 5 carbonyl carbon monoxide ligands, 5 into 2 plus 2. That would have been also given 18 electron. Are you able to follow me? Now,
Yes, sir.
Yes,
you
sir.
understood. Correctly, you have understood. But it's good that you have asked this for the benefit of others, not for you. Good. Therefore, plus 1 you have to add, because that 1 you should have added 2, because manganese is enjoying both the electrons. But out of that, 1 is already his. If manganese is a guy, not a girl. I'm just kidding. Then 1 electron is his. So you are adding the entire electronic configuration. So the other other electron you are taking, the other guy's electron you are taking into account. You are also sharing the other guy's electron. You understood? That is making me slow. Got it?
Yes, sir. Into sir 2 into coordination number coordinate coordination number 6 sir.
6 केमती हला 5 only 5. You have to apply the 18 electron rule for each individual metal ions or metal atoms in the binuclear or maybe polynuclear complex. For every metal atom, you have to apply the 18 electron rule. So for this and for this also, the same 18 electron rule is obeyed.
Yes.
Okay. So I had discussed everything before we enter into a more interesting isomerism. Yes, because some people, some question setter, they say, which of the following carbonyl complex formula is wrong? You apply the 18 electron rule to find out which formula is wrong. For example, somebody will give chromium carbonyl complex is CrCO5 pentacarbonyl chromium 0. Impossible. ये हो नहीं सकता. Chromium, it is possible for iron. Nickel के लिए 4 टेट्राकार्बोनिल निकेल 0. आयरन के लिए 5 पेंटाकार्बोनिल आयरन 0. क्रोमियम के लिए हेक्साकार्बोनिल क्रोमियम 0 because not possible. So here chromium is in 0 state. So this is 4s1 3d5. You know a field configuration, and that is 5 plus 1 plus 6 into 2, 18. So 18 electron rule is satisfied. But here this 5 plus 1 plus 10, 5 2s are 10, 16, it does not obey the 18 electron rule. So pentacarbonyl chromium 0 is never formed. Got it? The trick to exclude those which cannot be formed and to take the one which will be formed in the carbonyl complex. That is a rule of thumb. You can take it. Not an approximate. It is an approximate rule of thumb for other complexes, but not for carbonyls, right?
Yes.
Then effective atomic number is similar type. Similar type. It is equal to the actual atomic number of the atom in the unbonded state minus the oxidation state. That means the electrons lost by the atom plus 2 into coordination number. So what is including the valence electrons and those others which it is sharing from other guys? What is the effective atomic number? If that becomes equal to the atomic number of the nearest noble gas or less than that, then it is stable. Same thing. So effective atomic number and 18 electron rules are used interchangeably. The two terms are used interchangeably. For example, ferrocyanide ion. Find out the effective atomic number, whether it is becoming equal to the atomic number of a nearest noble gas or not. Iron atomic number is 26. Since it is in the +2 state, it is losing 2 electrons, -2. Plus, it is gaining 12 electrons out of 6 ligands. 6 2s are 12. So 36, the atomic number of krypton. So therefore, it is a stable complex. But what about ferricyanide? It is 35. Still, it
So
is less
screen
than.
recovery.
Yes. Not
So
able to
screen
see?
previous example freeze is
Huh?
So screen the previous example freeze is
You are not able to see my screen?
Yes, sir. Correct.
Sir, I cannot see.
Raise your hands. How many of you are not able to see my screen? No, not able to see my screen. Not able to. Yes, Udit is not able to see my screen. Then I will change it. No, others are able to see my screen. Don't worry. I will stop screen sharing and again I will share my screen. Now can you see?
Yes, sir.
Okay. You have understood 18 electron rule, Udit?
Yes, sir.
Now effective atomic number is similar type of rule. Nowadays effective atomic number nobody bothers. It is similar, same. Instead of finding the valence electrons shared by the central metal atom, you are finding the entire atomic number plus those electrons shared. That means plus 18. So it is equal to the actual atomic number minus the number of electrons lost, that is the oxidation state of the central metal atom, plus the number of electrons gained. It is 2 into the coordination number. So in ferrocyanide ion, it is 26 atomic number of iron minus 2. Iron is in the plus 2 state. So it has lost 2 electrons minus 2, gained 12 electrons from the 6 cyanide ligands. So it is 36 equal to the atomic number of krypton. But what about ferricyanide? It is in the plus 3 state. So the effective atomic number is 35. Therefore, the rule changed. Just like 18 electron rule, it is less than equal to or less than atomic number of the nearest noble gas to make a stable complex. Right? So you will find in normal complexes, not carbonyl complexes, normal complexes, there are many which violate the 18 electron rule as well as same as effective atomic number rule. Despite that also they are stable. But most of them will be either 18 or less than 18. Either 36, that is not only 36, 54, xenon also it is possible. Either, radon is also possible. But usually xenon is 54, krypton is 36, xenon is 54. So effective atomic number will be either equal to the nearest noble gas atomic number or less than that. So that is called effective atomic number rule, and more powerful is the 18 electron rule, which is still in use. Now I will be giving you an example of a compound having haptic ligands. This is dicey salt. We'll talk about that later. But I have given you an example that here we are using normal dentic ligands, trichlorido, and ethylene having two carbon atoms and double bond. Both the carbon atoms are simultaneously coordinated with the central metal atom. Therefore, I told you the bonding is very complex. We will not study until the end of the program, and by that time maybe one or two will be living with me. Will be staying with me. And this is called dicey salt, the first haptic compound having haptic ligands, dihaptic, eta2, and the name will be potassium trichlorido eta2 ethylene. It is a neutral ligand, but it's a dihaptic eta2, platinate 2 and hydrate. And it is a square planar complex. Platinum, 3 chloride ions, and the center of gravity of ethylene will remain in one plane, and that is square planar complex. But the plane of the ethylene will be perpendicular to the plane containing platinum and 3 chloride ions. This is very typical complex. And ferrocene is another example of pentahaptic ligand, cyclopentadienyl or cyclopentadienido. Each one is -1. C5H5 -1. Let me tell you, when I have listed this is C5H5 -1 is a anionic ligand, but pentahaptic ligand, maximum 5. All the 5 carbon atoms can together complex with the metal atom. So this is ferrocene. It is a sandwich organometallic compound, which I'll be talking about these sandwich compounds in details later. When we'll talk about carbonyl complexes, we'll also talk about the sandwich metal organometallic compounds. Here, 2-cyclopentadienide ion will be sandwiching the iron, just like we are here fond of taking in US. Most of us they love to take some form of sandwich. Two bread and the inner stuffing will be either egg, omelette type, or avocado, or some people cheese, some people many other things, and to make it tasty, some add some sauce, hot sauce. And I'm gaining my weight. I'm so sorry. I will not show you my face when I go to India. I'm eating so much. These guys, they are feeding me. But this is not their fault. It's my fault. I am taking. It's very tasty. Okay, this iron is in the +2 state, bound to be. Because if cyclopentadienide is -1, there are two. So -2, so iron is in the +2 state. So since both are identical and they are complex ligands, so bis eta 5, all the 5 carbon atoms in each, one upper, one below, each, the bonding is not as easy I have shown here. It will be all the carbon atoms will be linked, and the bonding is really complicated. The bonding is really complicated. So this is called bis eta 5 cyclopentadienyl iron 2. This is a sandwich complex. And this is the egg sandwich. I mean, between two, loaves of bread, and there is one stuffing. That is either bread or avocado. In India, avocados are very non-entity and very rarely available. Nowadays, they're available in once in a blue moon. But here, everywhere you find avocado. Here, this is benzene as one hexahaptic ligand. And here, although it is cyclooctatetraene, but only 4 carbon atoms are ligated. 1, 2, 5, 6. So you have to write down 1, 2, 5, 6 eta. Don't write eta 6. You do not know if you write eta 6. Then we cannot pinpointedly say which carbon atoms are connected. So write eta 6 benzene. Benzene, all the 6 carbon atoms are connected to cobalt. But out of the cyclooctatetraene having a top-shaped structure, only 1, 2, 5, 6 eta cycloocta, and the name IUPAC name is 1357 tetraene cobalt 1 plus, because this is 0 and this is 0. The both are neutral ligands, although haptic, but neutral. And since the elephant has a +1 charge, so cobalt has to have an oxidation state of +1. So with this, I really complete whatever information I wanted to disseminate in the first lecture. That is over. Now we go to the structural isomerism. Now, before we write, let me tell you, within 10 minutes, I will remind you first that isomerism is a phenomenon in which the formula remains the same, but the structures are different. If the structures are different, their names are different, their properties are different, and they are called structural isomers, having different names. But if the structures are same, but they are non-superimposable, the steric relationship of the groups and atoms, they are different, so the two forms they are not superimposable with one another. They are called stereoisomers. And in stereo, we have two types usually, for the optical isomers and geometrical isomerism and optical isomerism. Today, we shall be finishing the simplest structural isomerism of complexes. There are only 4 to 5 types of structural isomerism. One is the ionization isomerism. In ionization isomerism, the ions are different outside the coordination sphere, thus they are interchanged. In this, bromide ion is inside the coordination sphere, chloride ion is outside, but thus the opposite. Now chloride ion is inside and bromide ion is outside. If you add silver nitrate solution to the first solution, you will get a white precipitate of silver chloride. But if you add silver nitrate to the second solution, you will get yellowish white precipitate of silver bromide. So that is the beauty. You just write down structural isomerism number 1, ionization isomerism. The complexes differ in the nature of ions produced. Write in short the first line, and leave some space. You can write down the rest at home. The complexes differ in the nature of ions produced, that is, the ions remaining outside the coordination sphere are different. They are interchanged. This happens due to exchange of ions between inside and outside of the coordination sphere. And give this example and write the name. I give you 1 minute time to write the name under each, not structure. There is no need to draw the structure, octahedral structure, where in the first, I have drawn in the second, and at the second first, the bromide ion is outside the coordination sphere as free ion. Chloride ion is covalently bonded with the central metal ion in the second, and in the first, which I have drawn in the second, bromide ion is linked to the central metal atom, and chloride ion is swimming as a fish. Written? Have you written? So it is about 6:06. So I guess we can still have some time with us to finish this. So what is the name of the first one? Who can tell me?
Pentamine, bromido, cobalt 2.
Pentamine. Please don't allow
Bromido,
Krishna to sweep away. Others also participate. I know he has completed and I'm very happy about it. So also Udit. So he will sweep the name. Pentamine and bromido is inside the coordination sphere. It should be bromo or bromido. For us, it is bromido, and for many, it is bromo.
cobalt 2.
And then the metal cobalt. And what is the oxidation state? -1, -1. It is neutral. So it is +2 state. So cobalt 2. And this is what? Pentamine.
Chlorido,
Yes. Chlorido. That was
cobalt
bromido.
2.
This is chlorido. And I am sorry, I did not write the counter ion. I left. What I left?
Chloride,
Chloride at the end.
Fluoride.
And here it is pentamine, chlorido, cobalt, same to bromide. The formula are same, the structures are different, their properties are different. And I have given other examples. You can write down at home, leave some space. Write the other example and name it. Only example 2, where nitrite ion is outside in one, bromide ion is inside, and there is an exchange between bromide ion and nitrite ion. Nitrite ion is inside and bromide ion is outside. When you add silver nitrate, one solution will not give any precipitate. Silver nitrate is soluble, but two will give a yellowish white precipitate because bromide ion is outside. All I have written, everything I have written, you will write, but I want you to write the name, give the example, write the formula, and below it write the name, so that it will help you, because you are not practicing anything at home, most of you, so it will help you now. Yes? Girija, what is the name of this first compound? Anyone who are watching from a distance remotely in the YouTube? Yes, Udit?
Triamine, bromido, platinum 2, nitrite.
Triamine, bromido or bromo, platinum, how much? Because nitrite is
2.
-1, bromide is -1. Ammonia is a neutral ligand, so it must be in +2 state. Platinum 2, then nitrite. What is the name of this compound? Triamine,
Triamine, nitrito N,
nitrito N, or simply
platinum,
nitro. We will not dishonor nitro. Nitrito N, then
Platinum 2 bromide.
Platinum 2 and outside is bromide. You can see you take the example of Krishna and Udit. And other you write. This is, I have written deliberately O. It is SO4. Many books they will write SO4. The correct formula is the one in which the ligating atom, the donor atom is shown first. So I have broken down SO4 as OSO3. Otherwise, people may confuse that a sulfur ligand is there. It's not a sulfur ligation. It is oxygen donor. So OSO3 I have changed it. So heaven is not going to fall if you write SO4 instead of OSO3. So the name will be, who can tell me name of this compound? Need not write in your
Pentamine.
copy. Need not write in your copy. Leave a space. You write later. What? Pentamine.
Pentamine sulfato.
Sulfato.
Chromium 3 bromide.
Chromium.
Yes, because it is -1. Sulfate is always -2. So chromium is in the +3 state. What do you expect? Sulfato is acting as a monodentate ligand or bidentate ligand?
Monodentate.
Usually monodentate. Because monodentate because although it has 2 teeth, but it is biting under 1 teeth because usually the coordination number is 6 or 4. On usual cases, it can go above 3 and come below 6, come above 6 and below 6, but usually it is 6. So most likely it is acting as a flexidentate ligand here using, and the other example we saw before, it was using 2 teeth, bidentate, now 1 teeth. Doesn't matter. What is the name of this compound where sulfate is outside? When you add silver nitrate, yes, Sutki?
Pentamine chromium 2 sulfate.
Are you kidding me?
3 sulfate.
See, and here
Chromium 3 sulfate.
are you kidding me? What? -1, this is -2. So total negative charge is -3, so chromium is in the +3. So these are isomers. How the charge of the metal ion will be different, right? So bromido, pentamine, bromido, chromium, yes, Siddhi?
3
Chromium 3
sulfate.
sulfate. If you add barium chloride solution, you get a white precipitate of barium sulfate here. Not here. Not 1, but 2 will give you a white precipitate of barium sulfate. If you add silver nitrate, 1 will give you yellowish white precipitate, 2 will not. So they are chemically different because they have different different type of ion inside and outside the coordination sphere. Then comes, write down, linkage isomerism. These are very simple things. आगे आगे देखिए होता है क्या. In English, see what is going to happen when you enter into stereoisomerism. Your head will churn unless you become focused. And I assure you, I will make you understand if you are focused. If you are light-minded, just attending class for fun, it will go in vain, wastage of time. So here, the donor atom linking to the central metal atom, they are different. Same ligand, but different donor atoms. That is possible when the ligand is ambidentate. Ambidentate ligands are usually monodentate ligands, but they have 2 alternative sites of donation or ligation. If it is written NO2, nitrogen is the donor. If you write ONO, this becomes oxygen donor. Nitrite O, this is nitrate N. Nothing is different other than this. Write down this example. Definition and example. And many more examples I have given, you will write at home. So what is the name of this compound? Tell me.
Pentamine nitrate and cobalt 3 chloride.
Precisely. First, you have to find the oxidation state of the metal atom correctly. So outside there are 2 chloride ions of -2. And this amine is neutral. Nitrite is -1. So total negative charge is -3. So cobalt must be in the +3 state. So the name will be what? Pentamine
Nitrate and
nitrito N or simply nitro. Then
Cobalt 3 chloride.
I'm writing below that cobalt 3 chloride. And here, this is pentamine,
Nitrito.
nitrito, I'm sorry, no
Chloride.
bracket. Pentamine, nitrito O, cobalt 3 chloride. Same. The only difference is here nitrito O, nitrito N. Now see, their colors are different. Here nitrogen is the donor. Here oxygen is the donor. So their colors are, this is orange color, this is yellow color. This is nitrogen donor. This is oxygen donor, I'm sorry, oxygen. This is nitrogen, NO2, this is ONO. But their properties are different. They are called linkage isomers, and you write down the name of these two is SCN whole 2 and this is NCS whole 2. What will be the name is write down here. But remember, IUPAC has suggested for complex ligands, you can use bis in case of dye. You can use. Even you will be surprised to know that the actual IUPAC name of this compound is, if you write aluminium in between bracket III, that means 3 sulfate, it is okay, it is correct. If you don't write, then you have to write dialuminium trisulfate. Dialuminium. For monoatomic ligands or ions, you di-tri-tetra. But if it is polyatomic, even if there is no di-tri-tetra, you should use bis tris tetrakis. But usually we don't write. It will be dialuminium trisulfate. You will be happy. You will be very frustrated to know the IUPAC formula can be dialuminium trisulfate or aluminium 3 sulfate. You may not write tris or tri if you write the oxidation state that is in Roman. So I am showing you this, the new rule, the red book, which I have shown you once, the IUPAC original red book. The aluminum sulfate formula that C, here C, calcium phosphate, same type aluminum sulfate here. Calcium, tricalcium, bis phosphate, aluminum sulfate, dot potassium sulfate, dot 24 water. This is potash alum. This is aluminum trisulfate, dipotassium, only sulfate, and this is water. One 24. I will tell you what is 1:1:24 later.
Now mole ratio लिखिए.
Mole ratio 1:1/24, right?
Yes, sir. तीनटा अच्छा नहीं है तो
Oh, 1 oh yeah. So mole ratio 1:1:24. Aluminum sulfate 1, potassium sulfate 1, water. So it is not writing tetradeca hydrate. It is writing water 1:1:24. So this is funny naming system which we don't accept sometimes. So, but in complex we have to accept. So what is the name of this compound? Ethylene diamine, bis thiosulfato or thiosulfato. What is the name of this compound? Palladium. What is the oxidation state of palladium?
+2.
+2. Because thiocyanate is a -1, so this is total -2. This is +2. So this is ethylene diamine, single M, but amine is double M. Then bis,
Dithiocyan.
better write bis. For polyatomic ligands, bis tris can also be written, should be written with a priority to ditri-tetra, even if there is no ditri-tetra in the ligand's name. So bis what?
Thiocyanato.
Thiocyanato. Thiosulfato, no, not thiosulfato. Thiocyanato. Then palladium, what?
2.
2.
2.
And this one will be same ethylene
Ethylene
diamine
diamine B isothiocyanate palladium.
is isothiocyanate. Palladium 2. Now let us write down coordination sphere isomerism, but it is typically called hydrate isomerism or solvate isomerism or solvate. Hydrate isomerism is more popular as hydrate isomerism. A2 lecture, they write down from here. They differ in the number of H2O molecules inside and outside the coordination sphere. But I have written in a different way that the number of ligands like water, chlorine remain out inside and outside coordination spheres to be different. They should not also be ionization isomers. The ions outside should be same. Indirectly, it boils down to water. So it is better to write hydrate or solvate isomerism, where the water of crystallization will remain outside, and if it goes inside, it becomes a ligand. So the hydrate isomers differ in the number of H2O molecules inside and outside the coordination sphere. Write down this and give a heading hydrate isomerism. Coordination sphere isomerism, it can also be told in a broader way that can also include many other things other than hydrate isomerism. So you can write hydrate isomerism. So now see what is the name of this complex. Cr, I write OH2 because that is the real way, and I have forgotten to put a half square bracket. So what is the name of this compound? Quickly tell me.
Hexaqua chromium 3 chloride.
Hexa aqua chromium 3 chloride.
Hexaqua, write down immediately. Hexaqua chromium 3 chloride. Not trichloride, not required. If you are writing the oxidation state, there is no necessity of writing trichloride, chloride. Therefore, if you write aluminum sulfate, then aluminum 3, if you write, then sulfate is okay. Otherwise, trialuminum tris sulfate. Okay, then its color is violet. But now we are taking one chloride as a ligand and bringing one water outside. No covalent bond between this water and chromium, but there are 5 water which are covalently bonded with the central atom, but this water remains outside with hydrogen bonding interaction, not covalent bonding. So this will be called what? The color is different, gray green. It is pentaqua chlorido chromium 3 chloride monohydrate. Pentaqua chlorido or chloro, same chromium 3, then chloride, hydrate or monohydrate or simply hydrate. So what will be the name of this compound? Other hydrate isomer. We have taken one more chloride inside and taken one more water outside. So what is the name of this?
Tetraqua
Tetrachlorochromium
dichlorido
3
Tetraqua
chloride dihydrate.
dichlorido, guys and girls. This will happen if you are not prepared. I will have to allow those who have prepared throughout the holidays I gave you, and they have to sweep the class. There is no way out. That is why I always urge that you must prepare something before the next class. Tetraaqua dichlorido chromium, same 3 chromium, I'm sorry, chloride, then dihydrate. So interestingly, the chemical properties are different. If you add excess of silver nitrate to 1 mole of the first, you will get 3 moles of silver chloride. In the second, you get 2 moles of silver chloride. In the third, you get 1 mole of silver chloride. In another set of experiments, if you apply conch concentrated sulfuric acid as dehydrating agent, the first will not eliminate any water. The water molecules which are covalently bonded will not be removed by concentrated sulfuric acid. But the second one will lose one water molecule. Third one will lose two water molecules. The first one will not lose any water molecule because the one which are outside, they are weakly bonded by hydrogen bond. They can be easily removed by a dehydrating agent, concentrated sulfuric acid. All these you write at home. Leave a space. Then the fourth one, coordination isomerism. Write down. Write down the first sentence. This isomerism is shown by compounds having both cation and anion as complex. Both are mononuclear. Just like hexa aqua platinum 2 and tetrachloroplatinate 2. So this is shown by compounds having both cation and anion as complex ions. Then write these isomers are formed by switching the metal ions between the complex ions. Ligands are or the isomers differ in ligands bonded to metal ions. The metal ions are exchanged or one or more ligands are exchanged. Quickly write down. So it is in India, it is 6:26. Another 4 minutes, we will be finishing. Written? The isomers differ in ligands bonded to metal ions. In other words, the interchange of one or more ligands between the metal ions give rise to these isomers. Now see, this was tetramine zinc 2. First you have to find out the coordination number. So this -4, the entire positive charge should be +4. So it will be distributed equally by the two metal ions +2 +2. Because this is neutral ligand. So how you name it? Tetramine zinc 2 and this is tetrachlorido. You know, many questions I have borrowed by copy paste mode. They are chlorobromo iodocyanotype. I'm sorry, I could not correct it. I just gave it in a copy paste mode. And here also copy paste mode chloro. Should be chlorido. Tetrachlorido cuprate 2. This is just the opposite. The copper will come first because cations are written first. When it bonds with amine, then it becomes a cationic complex. So it will be written first. Tetramine copper 2 and tetrachloride of zincate. Now it becomes zincate. It was cuprate here, zincate here. Write down these two formula. Don't write this and write their names. What is the name? The name is also written. Tetramine. Here also there is a mistake. There should be double M. So many mistakes in copy paste mode. Double M. Tetramine zinc 2, tetrachlorido cuprate 2. Here the opposite. Tetramine copper 2, tetrachlorido zincate 2. And now write down the name of these two complexes which are called coordination isomers. These are called coordination isomers. When both cation and anion are complexes and the isomers can be interchanged, can be interconverted by switching of ligands or switching of metal ions. Write down this, the name of this pair. This and
Tetramine
this.
copper 2.
Tetramine.
Tetrachlor.
Amine.
Copper 2.
Copper 2.
Tetrachlorido.
Tetrachlorido or chloro.
Platinate 2.
Platinate 2. Why? Because the total negative ion is +4. There is no other negative ion. This is neutral. So it will be shared by the 2. +2 +2. If you make +3 +1, then the formula would be different. This will be 3, this will be 2. So 2 will come here, 3 will be coming here. So this is not given. So they have to be shared equally, +2 +2. Now, what is the name of this complex? It's isomer. What is the name of its isomer? Yes.
Tetramine
Tetramine.
platinum.
Why not you come forward? Tetramine.
Platinum 2.
Platinum 2.
Tetrachlorido.
Tetrachlorido.
Cuprate 2.
Cuprate 2. Good. and this one you write at home, and last but not the least, and you will see how quickly we can finish, because I have already told you how to name a binuclear complex with bridging ligands. Same thing will come here, that these type of isomerism called coordination position, just another word is joined here. This is only coordination, and this is coordination position isomerism, that is shown by polynuclear complexes having bridging ligands. They are formed by interchange of one or more ligands. So in the first, 4 amine here left side, 2 amine, 2 chloride in the right side. Here 3 amine, 3 amine, 1 chloride, 1 chloride. This is symmetrical. So you can have the option to write the name in many different ways, but here we have to write separately. This will be tetramine. First, you have to find out the oxidation number. This is -1, this is -1. Amido, hydroxido, this is -2. So total, so what will happen? This is X, this is X. So 2X minus 4 is equal to +2. The elephant has a charge of +2. So 2X is equal to +6. So X is equal to +3. So each cobalt is in the +3 state. So this will be tetramine, cobalt 3, mu amido, mu hydroxido, diamine, dichlorido, copper 3 ion, because there is no mention of any counter ion. Had it been chloride, Cl2, had it been sulfate, only one SO4, and so on, you would have written, instead of ion, you would have written sulfate or chloride. Then the interchange of ligands have made it symmetrical. These two sides are symmetrical. So either you can write triamine, chlorido, cobalt 3, mu amido, mu hydroxido, again triamine, cobalt, triamine, chlorido, cobalt 3 ion, or it is better that you mix them, right? Bis, mu amido, mu hydroxido to be brought first, then bis, triamine, chlorido, cobalt 3. So this is duplicated by writing bis, or you add mu amido, mu hydroxido, hexamine, dichlorido, dicobalt 3. To write down the name at home. Draw the structure and write at home. And finally, polymerization isomerism, which is really not a true isomerism. Rather, here the empirical formula are same. But we are excited to call this as a new isomerism for particularly coordination compounds, where the empirical formula is same. For example, the repeat unit is MLM. M is the number of ligands. N is the degree of polymerization, 1, 2, 3. So N can be 1, N can be 2, N can be 3. The ratio between the ligands and metal ions will be fixed. It may be 2 times, 3 times, 4 times, but the ratio is fixed. That is a new kind of isomerism called polymerization isomerism, where the empirical formula remains the same. They are, in fact, they are polymers. The isomers are polymers. Therefore, they are called polymerization isomerism. For example, this is diamine dichlorido platinum 2, and it's double. If N is equal to 1 here, the ratio between the amine ligand, chloride ligand is 1:1:1. 1:2:2. Then it will be 2:4:4. So the other, its dimer will be PtNH3 whole 4, PtCl4. Just you count, there will be 2 platinum, 4 amine, and 4 chlorido. So the name will be completely different. It will be tetramine platinum 2, and this will be tetrachlorido platinate 2. Similarly, here it is another example, cobalt example. I've given, this is another example that I'll give it 4. This is monomer, this is dimeric, this is same as dimeric, but different formula, different complex, and N is equal to 3. So this is triamine trinitrito N cobalt 3. This is hexamine cobalt 3, hexanitrito cobaltate 3. This 2 is the second complex, not the oxidation state. But the same N is equal to 2 can have different formula. This is tetramine dinitro cobalt 3, and this is diamine tetranitrito N cobaltate 3. The same number of cobalt nitrite and amine ligands in the ratio 2 is to 6 is to 6. This is 1 is to 3 is to 3. This is 2 is to 6 is to 6. It is same as 1 is to 3 is to 3. And here it is triple. There will be whole 2. Here it is whole 2. So this will be, you can find out, this is a nitro cobalt. If cobalt, supposing it is in the +3 state, is -4. So the net charge is -1 into 2. So -2. And this is also +2. +2. And this is -1 +1. So +1. There is something wrong here. This is -4. This is -1 and -2. This has to be +2. So tell me what is the wrong here in this? Who can find where is the wrong? If you can mark, you will find I have missed a 2 here. Because it will be 2 is to 6 is to 6. I mean, here that will be 4. So 4 here. Oh, this is same in the whole 2. Then this are same. No, there is some mistake. I will give you, since time is running out, I will give you the corrected version of this isomer where there will be 3. If this will be 3, and this will be 3 is to 9. Oh, 3 to the 6, 3. This 3, 2. 2 to the 4. 4, it has to be 5. And this will be 1. It was okay. No, that means this is also in +2. Supposing this is in +2, so this will be -4 +2 -2. This will be then this will be -2, and this will be +1. So 2 will be coming here, 1 will be here. So I have given 2 here. If it will be +3, this will be -4 -1, and its valency is actually 1. So 1 will be coming here. Its valency, if it is +3 -1, oh yeah, its valency is 2. 2 is coming here. Yeah. Okay, this is correct. Previously, what was there is C. This is +3. This is -4. So the net charge of the complex is -1. So the valency is 1 minus. And here this is +3. This is -1. So the valency is +2. So 2 is coming here. 1 is not written. So therefore, its name will be nitrite, pentamine nitrito cobalt 3. This will be, should not say di. It is automatically, once you are writing the oxidation state, you do not write bis. So simply tetranitrito N. This is only nitrito N, pentamine nitrito N cobalt 3, and this is diamine tetranitrito N cobaltate 3. Automatically 2 will come. Automatically, once you give the oxidation state, I write down the name. This is pentamine nitrito N cobalt 3, and this is diamine tetra nitrito N cobaltate 3. So this is the trimer, this is dimer, this is also the dimer, but having different formula. And this is the monomer. With this, we conclude today's session. Guys who are watching, quite large number of guys are watching from outside. So please let me know how you are feeling, and if you are really feeling this is helping you, please do not hesitate to hit on the like button, and also if you have not subscribed, subscribe to this channel. Many more videos will soon join to benefit you. Bye bye for tomorrow. Tomorrow will be most crucial. Then most crucial. Tomorrow will be stereoisomerism, and we'll be revising this. You write down everything at home. Those who have not completed nomenclature, complete it, please. Bye bye. See you
Thank you,
tomorrow,
sir.
same time.
Sir,
Thank you.
Thank you, sir.
sir.
Yes. Go.
सर ମୁଁ ପଚାରୁଥିଲି ସେ ଯୋଉ CrCO5 ରେ ଆମେ valence electron କାଢିଲୁ